Hello, ladies and gentlemen. Now let's talk about arc length and angle measure. Really about sector area is what we're talking about. So let me just help you understand where this formula comes from, and then maybe you can figure it out if you ever get stuck. Theta out of 2 pi. So this is some fraction of an angle. Theta is going to be some fraction of 2 pi being one whole revolution. Is S out of 2 pi r. Some fraction of, what's 2 pi r? That's the circumference. The arc length is some fraction of the circle. It's some fraction of the circumference. If you have the whole circumference, and I said like, well, if the angle is a quarter, hopefully it makes sense to you then that the arc length would be a quarter of the circumference. If the angle is a quarter of the circle, then the arc is a quarter of a circle. That's what this proportion is telling you. Oops. So what I'm going to do is move some stuff around because I want to get just S by itself. So I'm going to multiply both sides by 2 pi r. And what happens is this cancels out and you get S. But on the left side, the 2 pi cancels out, but the r survives. So the formula is r times theta, r times theta. And I'm going to write S equals r theta. That's the formula that you need to know for arc length. S is the arc length, r is the radius, and theta is the angle. The only trick is theta has to be in radians. If you don't use radians, this doesn't work. So just be careful because that's how I'm going to trick you, is I'm going to give you an angle that's in degrees, and you need to remember, first convert it to radians. Now we just practice converting them, but they might be on the unit circle, you don't even need to bother. So let's kind of draw what we're finding here. The arc of a circle, so I'm just going to draw part of a circle. 30 degrees, like that. Okay, there we go. It's a 30-degree arc. Radius is 10. And we use this word subtends. Subtends means this arc subtends that angle. It's sort of like saying it's formed by the angle opening up. Kind of way of thinking about it. Subtends the angle. We don't know the arc length though, S. That's what we're trying to figure out. So I'm going to use a formula. S equals r theta. S equals, do I know the radius? Yeah, 10. Do I know theta? Yeah, 30 degrees, right? If you do 30 degrees, you're going to get it wrong because must be in radians. So we got to make sure 30 degrees is in radians. That's on the unit circle. We know that's pi over 6. So it's just 10 times pi over 6. So if I want to figure out the arc length, I'll just do 10 times pi over 6. 10 times pi over 6. And I get 5.24. We'll say S equals 5.24. 5.24 what? Well, the arc outside, that's a length. A length in these units. So 5.24 meters. That's it. You just use a formula. S equals r theta. As long as you convert theta to radians, you'll be fine. Let's try another one. I think I moved the unknown, but it's going to look, I think it's something like that. All right, what do we know? The arc length is 6 meters, the radius is 4 meters, and we don't know theta. That's what we're trying to find. We're trying to find theta. So let's do S equals r theta. That's the formula. Do we know S, the arc length? Yeah, it's 6. Do we know the radius? Yeah, it's 4. Do we know theta? No, that's what we're trying to find. So to solve for theta, you divide both sides by 4, and 6 over 4 is 1.5. So theta equals 1.5, but 1.5 what? What's theta in? Remember, theta is in radians. So theta is in radians, 1.5 radians. Now you might remember what a radian is. A radian is the length that is formed from taking the radius and laying it along the outside. So if that was 4, if I took that 4 and I measured 4 along the circumference here, that would be 1 radian. But this is 6, so it's 1.5 radians. 1 times 1.5 times 4 is 6. So you take 1 radian, that gets you 4, and then the other 2 comes from half of a radian. So that's why it's 1.5. Sometimes it helps to kind of make sure you know what a radian is. Okay, this one says the car's wheels are 28 inches in diameter. So I'll be like, okay, 28 inches in diameter. All right, so this is 28. Okay. How many miles will it travel? If it goes 10,000 times? That's a lot of times around. All right. So here's what you need to realize. If you sort of unwind this circle, so now it's a straight distance. If I took this circle and I were to like stretch it out and open it up, that's a distance. What is the length of that distance? That's the circumference. If you unwind the circle, the distance that you create is the circumference. So this is pi times diameter. This is 28, oops. Or you could say 2 pi r, 2 times 14 is 28. 28 pi inches, that's the circumference. This would be 1 revolution. Now, if you want that, it's like, if it helps you to think about it as a decimal, 28 pi. That's 1 time around. If this circle spins around once, it'll go about 88 inches, just under 88 inches. So what we need to do is say, okay, well, it's going to do that 10,000 times. 1 time around is 88 inches. This is about 88, almost 880,000 inches. So I'm just going to leave this alone. I'm going to type it all in one step. I'm going to say 28 pi times 10,000. That's how many inches we will travel. This is in inches. And we're going to do some dimensional analysis because we're going to convert inches to miles. So the way we do this is we say if there's inches in the top, then I need to cancel out inches. So I need something about inches in the bottom. And I'm trying to get towards miles. So I might not know how many inches are in a mile. I do. It's 63,360. But if I don't, I'll just be like, it's 12 inches in 1 foot. I know that. So if you did this distance divided by 12, you would know how many feet there are. Great. I don't really care about feet. I'm trying to get miles. So I need to say, okay, I want to cancel out feet. What do I know about feet that are close to a mile? I know that there are 5,280 feet in 1 mile. So now my units, the inches cancel out, the feet cancel out, miles are the survivors. That means miles will be my unit. So I have to type it all in now. Well, I've done the top. It's that. But I'm going to do it all in one so you can see. 28 pi times 10,000. That's not 10. Divided by, and here's where you got to be careful. All of this stuff in the denominator needs to be in parentheses because order of operations say you need to simplify that first in order for this to work out correctly. So you get 13.88. 13.88 what? Miles. 13.88 miles. Okay, so if it goes around 10,000 times, you'll go just under 14 miles. All right. Other thing we might do is area of a sector. So this is very similar. Some fraction of the area is some fraction of the circle. It's the same thing as the front. Whatever the fraction of the angle is, will be the sector area will be that fraction of the area of the sector. So I'm going to also manipulate this one a little bit to give you another formula. Let me finish drawing. If you want to find the area of a sector, you multiply both sides by pi r squared. This cancels out. You get a equals. Now, the only thing that cancels out is pi. So you still have a 2 in the denominator, which I'm just going to write as 1/2 theta r squared. That's how I remember the formula. 1/2 theta r squared. So the area is 1/2 theta r squared. Again, theta is in radians, or it doesn't work. And we know, I'm going to do a problem now and kind of work through it. It says the area of the sector, we don't know. The central angle is 60 degrees. The radius is 3 meters. We're trying to find the area of the sector, though. So we're trying to find this area this time. So you just use a formula. Area is 1/2. Theta is not 60 degrees because it's in radians. We're going to say pi over 3. And the radius is 3. So 1/2 theta r squared. 1/2 theta is pi over 3. So pi over 3 times 3 squared is 4.71. So the area is 4.71. 4.71 what? Well, it's meters, but since it's area, it's meters squared, 2 dimensions. 4.71 meters squared. Try another one. Remember the formula is area is 1/2 theta r squared. So I'll draw a sector. Okay, something like this. I don't know if this is to scale at all. I don't care either. I know that the radius is 25 feet, and I know the area in this problem. So this is what I know is 125 feet squared. But what I don't know is theta, and that's what I'm asked to find, the central angle. It doesn't really, the wording of this is terrible. But anyway, we know the area is 125, 1/2. Theta, we don't know theta, so I'll just say theta. And we do know the radius is 25. So what I'm going to do is simplify the 1/2 times 25 squared and figure out what my coefficient is. So 1/2 times 25 squared. Half of 625 is 312.5. So 312.5 theta equals 125. Now to solve this, you just divide. I just move the variable around a little bit. So now it's 125. Oops. 125 divided by 312.5, which is 0.4. So theta is 0.4. 0.4 what? Radians. Theta is always in radians. So 0.4 radians. Half a radian. A little bit less than half a radian. All right, one more. We'll actually do this kind of word problem now. This says the top and bottom ends of a windshield wiper are 34 and 14 inches from our pivot. So what you got to realize is that these are sectors. Okay, that's forming a sector, these windshield wipers. Okay, right there, that's the sector of a circle. And that's the sector of a circle. But what I'm asked to find is the part it actually hits. So the green part now. So to find that, you got to think, how am I going to find that green part? Well, to find the green part, you're going to take the yellow part and you're going to subtract out the red part. So the yellow part, we'll say that's the area of the big windshield wiper, and we're going to subtract out the area of the little windshield wiper. So we'll just use the formula twice. Area is 1/2 theta r squared. 1/2 theta r squared. So 1/2 theta, 135 degrees. Remember, you got to make that radians. That's on the unit circle, so 3 pi over 4. 1/2 theta r, the big one is 34, minus 1/2, same angle, 3 pi over 4. The radius here, though, is 14 squared. So you can type it straight into the calculator. It's pure calculator work. I'm going to do 0.5. 0.5. 3 pi over 4 times 34 squared. Now make sure you are practicing typing these in, because even when I give people calculators, they mess it up. You got to be pretty proficient with your calculator here. 14 squared. I should close the parentheses first. It doesn't really matter, but I want to be careful. It doesn't matter in this problem. Squared. 1130.97. 1130.97. So 1130.97. What? It's an area. It's in inches, so it's inches squared. 1130.97 inches squared. Okay, so that's arc length, sector area. We're going to use these things to do some speed problems. We'll start to apply them a little bit, but for now, you're basically just kind of using two formulas, and that's really it. So you do have a math lab. You can definitely get done now over angle measure and arc length, so get that done. And maybe while you're logging in, hit the like and subscribe button.